Hi there, it's Mr. Cardozo again, and we're back with video lesson number 5 on Intro to Objects in Java. And we're just going to do a couple more examples with instance methods, but as well talk about some of the nitty-gritty, making sure you understand some important concepts behind pass-by-value and pass-by-reference. So let's get right to it. Last time we went in detail about multiplying two fractions, f1 and f2, from this class using the times method. I didn't finish the example really, but this prod now can be printed out. So just like before, we can put that prod here because prod is a fraction. So what is it going to do? You can do prod.toString, or you can leave out the toString because remember last time in the last video lesson, I said toString is special. You don't actually have to put the .toString if it's in system.out.println. So we can leave out the toString, and so basically two instance methods are being called here. One for times, it's going to multiply f1 by f2, place the result in prod. We went through that in detail in the last video. If you didn't get that, or if you don't understand the details of that, make sure you go back to that video lesson number 4 and watch that. And then over here, because prod is now a fraction, prod will get printed out by using the toString method. Okay, so that let's just compile that all up. And sorry, I had another class here set up for you. So let's compile that and let's run it. And you can see it says my fraction is 3/8. Well, I probably should have changed that messaging. But prod is 3/8 because it's multiplying 1/2 times 3/4, which gives us 3/8, and that's what's printing out here. So you can see that multiply or that times function is working. And now we can actually multiply two fractions, and that's great because our fraction class is getting a little bit more useful. You could probably, if you experiment with this a little bit more, you'll see that it doesn't reduce the fraction or anything like that, but we can slowly add that as an instance method. So let's do another instance method before we get into the a little bit more complicated stuff. So let's go back to, before we do that, let's do another instance method here. So I'm going to go back into the fraction class, again making it more useful. So what's another method that might make this class more useful? How about knowing the size of a fraction? So we're going to define a size, so for example, basically by its decimal value. So if I have, for example, 1/2, this is equal to 0.5. And so we'll call this its size. If we have, say, let's say 7/2, this is equal to 3.5. So this is its size, and so this fraction is bigger than this one. What about, for example, which fraction is bigger? 6/8 or 2/3? Okay, so I'll let you figure that out, but we can easily convert these into decimals like you would in your math class and figure out which one is bigger. So the size function might be useful for a fraction. So let's go ahead and write that. So I'm going to start with public. Now, what is it going to return? What is the return type? What is the answer? That's how I always think. What is the answer to what I'm trying to do? So I'm trying to find the size of this. The answer is 0.5. Here the answer is 3.5. It's a decimal value. So the return type should be a double corresponding to that decimal value. And then we want to give a name for this method. So what's a good name for this method? How about size? Because we're calling it the size, or we can call it something like 2decimal. I think in the textbook they call it size, but here let's be a little different. We'll call it 2decimal. Now, inside this bracket, we need to decide, do we need to take anything in as input to this function to be able to do what we're doing? And the answer is no. The reason why we don't need to take anything in is because we already have the implicit fraction object, this fraction, the one that's going to be calling this method in the first place. And we don't need to figure out the size of any other fraction, so in this case we can actually leave it blank. This is similar to the toString method, and this is why we didn't have any parameter inside toString because we're going to print out or send back a string representing the current implicit fraction object. And here we're going to send back the size or the decimal value of the current implicit fraction object. Okay, so we don't need to declare any fractions or anything like that. We have one to work with. So we just want to return this .num divided by this .den. And you'll probably see that that's not going to work properly 100% because of integer division. So this .num is an integer, this .den is an integer. Integer divided by an integer will give you an integer. So for example, if the num is 1 and the den is 2, 1 over 2 will actually give you 0. So in order to make this work, we can cast one of these as a double, and now it should do regular division and return that. So let's go back over here to our fraction calculator where we're testing all of this stuff out. And now because we are, getting a double, so we're going to say double, and we'll say decimal value, let's say. And then we can say decimal value gets, and let's say we want to find the decimal value of f2. That's nice and easy to verify. It's 3 over 4. So we can go f2 dot decimal value, open close brackets, and then we can print out, the value of, let's say, f2 is, and then we can say decimal value. So let's say the decimal value. So now what this is going to do is, this one right here, it's going to find the decimal value. F2 is going to be the implicit object, fraction object. So when we go back in here, F2 is the this. So this .num and this .den, F2 represents the this. So it's 3 over 4. It's going to return that as 0.75. And it's going to store it in here, and then it's going to print this out, and I'm just going to get rid of this for now. So compile all that, and I have an error. What did I do? Oh, I didn't spell it right. Decimal, two decimal. Gotta get the name right. 2 decimal. Great, so let's compile that. And now we've got a warning, don't worry about that, and hit run. And it says the decimal value of 3 over 4 is 0.75. I could do F1, and now it'll say, oh, the decimal value of 3 over 4 is 0.5. That's not correct, but that's because I didn't change my print statement here. So that should be F1. There you go. So we have another instance method that's useful that can be used on a variety of fractions. Okay, and that works the same as other fractions. Now, to get to the little bit more complicated stuff, we're going to talk about pass by value versus pass by reference. Now this is the most confusing thing we've done so far. These are for primitives. I can't write. Primitives, and these are for objects. Okay, so primitives are like int, double, booleans, all the basic types, and pass by reference is for objects. Now, before we do that, let's go to an example that I've created here. And let's just work with primitives. Let's see how pass by value works first before we do anything else. So in this main method, I'm just going to make an integer called x. And I'm going to assign it the value of 3. Now I've created this method called, and I notice I put static in there because I'm not working with an object. So public static void change x. So this method does not return anything. It's called change x, and it takes an x as an integer. Now, or it takes an integer as a parameter, I should say. This x just happens to be called x. It's not necessarily the same x as this one. Okay, so these are both local variables to their methods. So now I can say x gets 7. Okay, and now I'm going to go down here and print out x. System.out.println x. Well, what do you think prints out? So I'm going to compile that and run it. So x is 3, 3 gets mapped into here, it changes to 7, but we don't return anything. So what prints out down here? Hopefully you said 3. And 3 would be correct because, again, the x gets mapped into here. So in reference types, so we've created this, in primitive data types like integers, we've created this x, this x as an integer here, and it's got a 3 in it. Okay, that's from the main method, so this is in your main method. And then we pass it into your changeX method. Okay, and it also gets mapped into another variable called x. So these two are not the same variable. I named them the same on purpose so that you know, just because they're the same variable doesn't mean that the variable name doesn't mean they're the same variable. So this 3 now gets copied over here, right? And so when you change this one, so then we change this one and we say, okay, now it's 7. Well, back in the main method, it's still 3 because it was copied over. And this is what it means to say pass by value. Now, objects do not work the same way. Okay, so if we have, in our fraction class, when we pass in an object, it actually it sends a reference to that object to that method, like a pointer. So, for example, if I were to change anything, it would in fact change. So let's say, for example, I just made a method in my fraction class. So I'm back in my fraction class here, and I go public. Let's say void, and I'm going to say change me. And again, it's going to change the implicit fraction. So now if I go this dot num gets 0, and this dot den gets 0, and we know that's bad, because 0 over 0, what does that even represent as a fraction? So if I do that, and I go back here to my, I can even do it here in this example here. So I can make a new fraction. Let's say fraction f1 equals new fraction 1 comma 2. So that's a perfectly good fraction. And then I go system.out.println f1. So let's compile that. I keep getting ahead of myself. We haven't covered in constructors yet. But if you have, you would know what I was doing there. f1.num equals 1, and f1.den equals 2. Now if I were to try that out, and it says 1 over 2. So that worked perfectly fine. Now, if I go f1 dot change me, because that's what I called this method here, change me, which just sets it to 0 and 0. f1 dot change me. Now what happens? Does it actually change here? Well, yeah, unlike the x, it does change. So what happened in this situation is we created a fraction object, in this case called f1, and this is in our, our main method. So this is on our main method. We created f1, and we said it's 1 over 2, right? And then we sent f1 into our change me, and this was in our fraction class. Now what it does is it sends the object, the pointer to the object, so it sends this little arrow, if you will. And so now when change me comes in here, it goes, hey, listen, I'm pointing, or this is pointing at this one. It's pointing at that same object. So now it says set this dot num to 0, as we did over here. This dot num gets set to 0, and this dot den gets set to 0. So this is pointing at the same fraction. It didn't make a copy. And so this one gets set to 0 as well. And so that's why it did change back here in the main method. As you can see down here, it did change. So I hope that makes sense. We'll talk about it a little bit more next time as well. Thanks. Bye.